Welcome to Astronomy Daily, your regular dive into the cosmos with me, Anna. In this episode, we're uncovering a centuries-old mystery of a famous star, marveling at how NASA fixed a camera millions of miles away, and getting ready for an epic total solar eclipse, plus a quick look at upcoming launches from around the globe. So let's get started. Our first story shines a light on Betelgeuse, the famous red supergiant that has baffled astronomers for millennia. Now, scientists have finally spotted its hidden stellar companion, a discovery that has cracked a 1,000-year-old mystery surrounding its behavior. For centuries, Betelgeuse has puzzled astronomers with its varying brightness, particularly a regular dimming over 6-year periods. This is distinct from the more dramatic Great Dimming of 2019 and 2020, which, though solved in 2023 by a giant dust cloud, sparked intense supernova speculation. It was the consistent, millennia-old 6-year heartbeat that remained the profound enigma. The breakthrough came from reviewing archival data, leading scientists to theorize a hidden companion. Despite challenges with instruments like Hubble, a team led by NASA Ames Research Center scientist Steve Howell persevered. They utilized the Gemini North Telescope and its Alopiki instrument, employing speckle imaging to cut through atmospheric distortions with short exposures. This advanced technique provided the high-resolution images needed to directly detect Betelgeuse's faint companion for the first time ever. What they found is truly fascinating. This companion star, believed to be a hot, blue-white star with about 1.5 times the Sun's mass, orbits Betelgeuse in an incredibly tight embrace, roughly 4 times the Earth-Sun distance. This places it within Betelgeuse's extended atmosphere, marking the first time a companion has been detected so close to a red supergiant. The irony lies in their life stages. Betelgeuse rapidly nearing its end, while its companion, though formed at the same time, hasn't even begun to fuse hydrogen in its core yet. Sadly, this doesn't promise a long life for the smaller star. Betelgeuse's intense gravity will likely drag in and devour its companion within the next 10,000 years. This groundbreaking research not only solves a millennia-old puzzle about Betelgeuse's brightness, but also paves the way for similar observations of other red supergiants. Astronomers anticipate another look at this unique system in November 2027, when the companion reaches maximum separation. The team's findings were recently published across 2 papers in the Astrophysical Journal. Next, we turn our gaze to Jupiter, where NASA's Juno spacecraft team recently pulled off an incredible feat, rescuing its radiation-damaged JunoCam imager using an experimental technique. This ingenious solution not only restored the camera's ability to capture stunning images of Jupiter's volcanic moon, Io, but it also provides vital lessons for future missions operating in the harsh radiation environments across our solar system. JunoCam, a color visible light camera, is located outside the spacecraft's titanium-walled radiation vault, leaving it exposed to some of the most intense planetary radiation fields in our solar system. While it was designed to withstand the first 8 orbits, no one knew how long it would truly last. It performed normally through Juno's first 34 orbits, but by orbit 47, hints of radiation damage began to appear. And by orbit 56, nearly all images were corrupted. Pinpointing the exact damage from hundreds of millions of miles away was a challenge, but clues pointed to a damaged voltage regulator critical for JunoCam's power. With few options left, the team turned to a process called annealing, heating a material for a period before slowly cooling it. This technique can sometimes alter a material like silicon at a microscopic level, potentially reducing defects. They commanded JunoCam's heater to raise the camera's temperature to 77 degrees Fahrenheit, much warmer than its typical operating conditions. And to their delight, soon after the annealing process finished, JunoCam began cranking out crisp images for the next several orbits. However, Juno was flying deeper into Jupiter's radiation fields with each pass, and by orbit 55, the imagery once again started showing problems, full of streaks and noise. With a close encounter with Io just days away, it was a Hail Mary moment. The team decided to crank JunoCam's heater all the way up, hoping for a more extreme annealing to save them. For the first week, test images showed little improvement. Then, dramatically, just days before the Io encounter, the images began to improve significantly. By December 30, 2023, when Juno came within just 930 miles of Io's surface, The images were almost as good as the day the camera launched. They captured detailed views of Io's North Polar region, revealing mountain blocks covered in sulfur dioxide frosts rising sharply from the plains and previously uncharted volcanoes with extensive lava flow fields. Although the image noise recently returned during Juno's 74th orbit, the Juno team has already applied variations of this annealing technique to several other Juno instruments and engineering subsystems. This pioneering work is teaching scientists how to create and maintain spacecraft tolerant to radiation, offering insights that will benefit not only defense and commercial satellites, but also future NASA missions, helping us push the boundaries of space exploration even further. Get ready to mark your calendars for August 12, 2026, when a total solar eclipse will sweep across a select part of the northern hemisphere, bringing the breathtaking spectacle of totality to Greenland, Iceland, and Spain. For those planning to chase this incredible event, now is the time to prepare, as a perfect eclipse trip often requires months, if not years, of meticulous planning. To truly witness a total solar eclipse in all its glory, you absolutely must be within the narrow path of totality, the precise strip of land where the moon completely blocks the sun. Even a 99% eclipse leaves the sun's dazzling disk exposed, meaning the ethereal beauty of the corona. The sun's ghostly outer atmosphere remains hidden, so choosing your location wisely is paramount. For the adventurous, Greenland offers pristine Arctic landscapes, particularly in Scoresby Sund, which lies entirely within the path of totality. Many will experience this from expedition-style cruise ships. Here you could witness up to 2 minutes and 17 seconds of totality, with the sun about 25 degrees above the western horizon. While travel costs are high and the weather is a consideration, meteorologist Jay Anderson notes that air flowing off the ice cap often dries out, leading to clear skies, though large weather systems can still pose a challenge. This is truly a bucket list trip, offering far more than just the eclipse itself. Iceland presents one of the most photogenic landscapes on Earth, boasting the longest totality on land at 2 minutes and 13.7 seconds. The path crosses the most populated areas of the country, specifically the Reykjanes Peninsula, the Snæfellsnes Peninsula, and the Westfjords. Eclipse chaser Sævar Helgi Bragason warns of heavy traffic, especially since the eclipse falls on a Wednesday, and many locals will be heading into the path. Icelandic weather is famously unpredictable, often changing completely in just 5 minutes. However, it's rarely entirely overcast in August, with always a hole somewhere. So, staying mobile and relying on excellent forecasts from the Icelandic Met Office will be key. Getting close to the water on one of the peninsulas could also offer better conditions due to onshore flow. Most travelers, however, are expected to flock to Spain, which will experience its first total solar eclipse since 1905. The path of totality cuts a diagonal track across the northeast, from Galicia to Catalonia, with the longest duration, about 1 minute and 44 seconds, occurring just before sunset. Spain's mountainous terrain, particularly the Cantabrian Mountains, the Meseta Plateau, and the Iberian System, means that choosing a spot with an open view is essential. The new eclipse viewing map from Spain's Geographic Institute can help observers avoid blocked sightlines. While August cloud cover averages less than 50%, late-day storms are common. Travel around Spain will be relatively easy, but be prepared for significant traffic, as many locals from Madrid and Barcelona will be heading into the path. Accommodation could also be tricky due to peak vacation season. Experts strongly advise against attempting to drive back to major cities immediately after the eclipse to avoid potentially millions of people on the roads. Instead, consider staying overnight in the path. This offers another astronomical treat, the Perseid meteor shower, which peaks just a few hours after the eclipse on August 12th to 13th. Rural skies will also provide a stunning view of the Milky Way arching across the southern sky. Whether you choose the icy fjords of Greenland, the dramatic landscapes of Iceland, or the plains of Spain, the experts agree on 3 key strategies for chasing this event. Plan ahead, check weather forecasts diligently, and stay mobile. Witnessing the 2026 total solar eclipse will undoubtedly be a moment you carry for life. And if you happen to miss this one, don't worry. Spain will host another total solar eclipse exactly 1 lunar year later, on August 2, 2027. Now let's shift our gaze from distant stars to the rockets preparing for launch right here from Earth as we bring you our global launch watch. This week promises to be an exceptionally busy one in space, with 8 launches on the docket, highlighting the incredible pace of global space endeavors. Leading the charge are multiple SpaceX Falcon 9 missions. From Vandenberg Space Force Base in California, a Falcon 9 is set to launch NASA's Tracers mission, consisting of 2 satellites designed to study magnetic reconnection and its effects on Earth's atmosphere. This mission, scheduled for Tuesday, July 22nd, will also carry at least 3 other rideshare payloads. The booster is expected to return to land at Landing Zone 4. Meanwhile, on the East Coast, the Cape Canaveral Space Force Station in Florida is bustling with activity. SpaceX's Falcon 9 was initially scheduled to launch the O3B mPOWER 9 and 10 satellites for SES-owned O3B networks on Monday, July 21st, though that launch was scrubbed due to unspecified reasons, with a new attempt possible on Tuesday. If successful, this would mark the 90th Falcon 9 mission of 2025, utilizing booster B1090 for its 6th flight. Shortly after, on Thursday, July 24th, another Falcon 9 will launch the Starlink Group 1026th batch of V2 mini-satellites into low Earth orbit, further expanding the Starlink constellation. The efficiency of pad turnarounds at SLC-40 continues to be remarkable. Looking internationally, China's Hyperbola 1 rocket is expected to launch on Friday, July 25th, from the Jiuquan Satellite Launch Center. The mission's payload remains unknown, and this will be its first flight since a previous launch failure in July 2024. Russia is also preparing for action, with a Soyuz 2.1B rocket set to launch a pair of Ionosphera M satellites from the Vostochny Cosmodrome on Friday, July 25th. These satellites will complete the 4-satellite Ionosphera constellation, which aims to observe Earth's ionosphere and enhance our understanding of geomagnetic and solar storms. This mission will also deploy 17 CubeSats. Europe's space ambitions are on display, with Vega C's second mission of 2025, launching from the Guiana Space Center in French Guiana on Saturday, July 26th. This mission will deliver 5 payloads to sun-synchronous orbit, including Microcarb, a microsatellite designed to measure atmospheric carbon dioxide levels with high precision, alongside 4 Airbus-built satellites for Earth stereo imagery. Back in the U.S., another Falcon 9 launch for Starlink, Group 17-2, is scheduled for Friday, July 25th, from Vandenberg, adding to the constellation's polar shell. Finally, a highly anticipated launch comes from Australia, where Gilmore Space will make its 3rd attempt at launching its Eris rocket on Saturday, July 27th, after previous delays due to operational issues and unfavorable weather. This Test Flight 1 mission from the Bowen Orbital Spaceport is poised to be a historic moment, as it aims to be the first orbital launch from Australian soil performed by a sovereign-built vehicle, and if successful, the first for a hybrid rocket design. The 25-meter-tall Eris rocket, featuring proprietary Sirius hybrid engines, represents a significant step forward for Australia's burgeoning space industry. Finally today, in a late-breaking story, we bring you news from Iran, which yesterday conducted a suborbital test of its COST satellite launch vehicle. According to the semi-official Tasnim news agency, this test was aimed at evaluating new technologies developed by the country's domestic space industry. While specific details about the technologies being evaluated were not provided, the report stated that the test's primary goal is to gather data that will be used to enhance the performance of Iran's future satellites and space systems. We'll be sure to update you as more details come to hand. And that's all for this episode of Astronomy Daily. I'm Anna, your host, and it's been a pleasure sharing these cosmic updates with you. For all the latest space and astronomy news, with our constantly updating newsfeed, and to catch up on all our back episodes, visit our website at astronomydaily.io. You can also subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts to ensure you never miss an episode. And finally, please share our podcast with anyone that you think might be interested. That would help us a lot, and I'd be incredibly grateful for your support. I'll be back tomorrow with more news from the cosmos. In the meantime, keep looking up.